All right, the last video for Mod 6 here, the PMT, IPMT, PPMT formulas. One of the most important, most useful things you guys will ever use if you choose to anyway. If you are buying a house, buying a car, getting a loan for anything, personal loan, school loan, anything like that, this is definitely the best information you can use. So for example, I have this one right here. It's for different types of vehicles here. So a 45 passenger bus, car number 20, whatever that is, car number 21, whatever that is, a van, 20 passenger, or a 35 passenger bus. So all these are different amounts of a purchase price. These are different loans, lengths, different interest rates, okay? So what we're going to do is, the first thing I'm going to do is show you guys the payment amount. So first payment amount is equals payment formula, PMT, okay? Calculates payment for a loan based on constant payments and a constant interest rate. So this is not a variable interest rate loan. This is not one of those loans that you start out paying a little bit and then 5 years in, it's like a balloon mortgage and you pay a whole ton. It's the same amount every single month, no matter what, until it's done. So if you're not sure where those things are, again, you can go to the formulas, and inside of these is where you would go for it. Financial has a lot of these in here, like FV is future value. IPMT we're going to end up using, and PMT and PPMT, okay? There's a PV also as a principal value, or starting rate, present value of the loan. So we'll talk about those in a little bit, but right now the payment amount equals PMT, okay? And there's going to be a rate, and this right here, I highly recommend you guys open this up, because this is going to remind you every single time that the interest rate is per period for the loan. So for example, 6% divided by 4 if you're looking for quarterly payments. If we are looking for a monthly payment right here, and this is a yearly interest rate, I have to take the interest rate and divide it by months in a year. So this one is quarterly, so it divides by 4. This is a yearly interest rate. I'm looking for monthly payments, so I'm going to divide it by 12. Okay? This is a reference, by the way. We're referencing this cell. The number of periods, number of payments. Well, length of the loan is 10 years. How many payments are you going to make over the 10 years? Well, it's 12 payments per every single year. So this one I'm going to multiply by 12 to have a total of 120 monthly payments. Depending on what this is, this could be in terms of months already. So please be careful and pay attention to what you're doing. If it's in terms of months, you don't do anything. You just use it. Okay? If it's in terms of years, you got to make it a monthly piece, because this gives a monthly payment. All right? The PV, present value, that's the starting amount. How much is the loan worth that you're taking? In this case, that's the purchase price for us. Okay? Now this one right here, FV, we generally don't need it. 2 reasons. 1, you see a difference here. This is bold. This is not. Okay? Anything that's not bolded or bold in, I don't know. Anything that does not have bold formatting is optional. Now this is the future value. If it's blank, it automatically assumes that your payments are going to go until the loan is at a 0, or it's paid off completely. So that's what we're going to leave it as, is base it off. And look what the value is. It's a negative $2,053. Okay. Now, negative numbers come up red in Excel. Okay. There are different ways you can do those. And again, you guys should have seen this when we were going back through the Home tab number group. And, whoops. And I open up the formatting group. You could have negatives with a negative number black, negative in red, parentheses mean negative, parentheses means negative with red. So in order to keep this thing so it's easy numbers for us to work with, what we're going to do is I always put a negative in the front. Okay? So I know that's going to be a negative. It's going to be a debt. We owe this money, so it's negative. So what happens when you have a negative negative? 2 negatives they negate each other, sorry, and it ends up being positive. So now we have positive values that we're working with. Okay, so that is $2,000 a month in order to pay for this 45 passenger bus at an interest rate of 6. This is why, again, it is so important to make sure you reference everything. If this interest rate changes to 5.5%, that automatically changed. I did not have to retype everything in a formula. This is why I want you guys to always make sure you reference everything. Do not ever retype anything in Excel. If it's typed in a cell once, do not ever type it again. Okay? The amount to the principal on the first month. So now this is the interesting. How much goes to principal? How much goes to interest? You're paying the bank $2,000 for this particular one. And in fact, I'm going to drag this down because I have nothing referenced, right? So each month works out well. Okay? Nothing was absolute reference. Everything was just cell referenced or relative referencing. Okay? So I dragged it down. We have all the payments. On the very first month, how much goes to the principal or the actual balance of what you borrowed of $185,000? Well, that's the principal payment. Or what we're going to use is PPMT. Okay? So equals negative, because it's going to be a debt. It's going to come out red. I don't need that. So we're making a negative is really what it is. PPMT. And we're looking for the rate again. The period, NPER, and PV. So I'm going to open up the dialog box again for you, just so you can see. Now my rate, again, I'm looking for monthly principal payments. So this is a yearly rate divided by 12. I'm going to skip this for 1 second because NPER we saw, the total number of periods we're going to pay it on, right? Well, 10 years times 12 payments per year. The principal value, present value, how much is a loan worth? Originally, it's this much worth. Leave it blank or put a 0 because you're going to pay your loan off, right? So the PER, this is the thing that's new. This is not in the regular PMT payment function, but it is in the PPMT and it is in the IPMT. I for interest payment. How much goes to principal? How much goes to interest? The amount that goes to interest is really what the amount that goes into the bank's pocket is really what it boils down to. So that's saying I want on the first month. This specifies the period and must be in a range 1 to the NPER, or 1 to, in this case, 120 payments total. What happens with these types of loans is the beginning loans, the interest is very high. And the amount that goes to your actual loan is pretty low. Banks, and they all do this on purpose because they want to get their money first. They want theirs. They don't care what happens to you. So if by chance in 5 years you default on this loan for a house for 30 years, they got a whole bunch of money from you in interest only, and they get to keep the house. And then they'll sell the house and make money on top of that. So you don't actually really chip away at your mortgage or whatever you're purchasing in the beginning of it. It takes a while before it really starts to take effect. So, and I'll show you guys that in a little bit. But right now, I'm looking for the first month, so PER is 1. Okay? So if I click OK, of this $2,000, the $1,100 of it goes to actually pay off this $185,000 loan. The rest of it, we can find it from here, equals negative IPMT. And again, the negative is to make it a positive looking number in here. I for interest payment. Again, the rate divided by 12. The period is the first month. I'm looking for number 1. NPER, the years times how many payments per year. And PV is how much am I going to borrow. The FV, final value, is automatically set at 0 because we're paying our loan off. So on that very first month, I'm going to give the bank $2,000, over $2,000. They're going to keep $850 and say, thank you very much, and then only put this thing on the $185. It's frustrating, okay? So what about halfway? Well, what's halfway? Well, if you're making 120 payments, wouldn't halfway be the 60 mark? So let's try that for principal. Equals negative PPMT for the principal. So the rate divided by 12, 60, since I'm making 120 payments. This times 12, and PV. Okay. And in fact, there's a better way to do this than 60, because what if this changes, right? I want halfway through. So I'm going to take the exact period, NPER. I'm going to put C8 times 12, and I'm going to divide it by 2, because I want halfway, right? Whoops. So let me get this thing inside of here. I'm going to put parentheses so I follow PEMDAS, right? So I'm going to follow the whole total amount and divide it by 2. So halfway through, I give them $2,000 a month. They're going to take $1,500 and put it onto my actual loan. And the bank is actually going to negative IPMT, do the same thing, and this divided by 12. This times 12 divided by 2, and I forgot the beginning parentheses. Remember, PEMDAS matters for this stuff. This is going to be the number of payments times 12, or the years times 12, and then that value. So halfway through, I'm giving them $2,000. They're keeping almost $500. They're still taking a good chunk of my pay, and they're not even applying it to my loan. That's not cool with me. And the last month, so equals negative PPMT. See how bad it is or how good it is at the end. This divided by 12. The period, this times 12. It's my very last payment, right? And how many payments were there originally? 10 years times 12 payments a year. So I'm looking for my last payment. This is the last payment. It's 120. How many total payments were there? 120. The original value was here. So on that last payment, hey, that's a good thing. Out of the $2,007, $1,998.58 goes to actually paying off my actual loan. And negative IPMT will show, whoops, that it's only a few dollars that's going to go to the pockets of the bank. And one more. So they only get $9 on the last time. Okay. And again, because these are only cell referencing, so relative references, I could drag these all down and it'll work for all these pieces. So depending on what happens here, let's say, forget this is a bus, right? You bought a house for $185,000. You have a 30-year mortgage. You're paying $1,000. How'd the payment go down? Well, if the longer you're having the loan, the longer you have to pay it off, the less money they'll take from you. But look what happens. The amount on your first month, only $200 of that $1,000 goes to paying your loan off. $850 goes into the pockets of the bank. So the longer the loan is, the more they're going to take in the beginning, and the smaller your payment is. So that's your trade-off. The longer the loan, you get to pay them less, which might be good for your budget. But your interest that you pay to the bank and you don't ever see it again is no good. And even halfway, this is halfway through, right? So this is 30 years is C8, right? So it's 30 years times 12 is 360 payments, right? Divided by 2 means 180 payments. And this is C8 times 12 is a 360. So this is the period we're looking at, the halfway point, out of a total of 360 payments. And because I'm paying the bank $1,050, they're going to take $450 and put it on my loan. And they're going to say, thank you very much for the past 15 years. I know you've been paying a lot, but I'm still going to take almost $600 from you. And you're only going to pay $450 towards your actual loan. The bank's getting theirs in the front, okay? They're taking their money in the beginning. So I'm going to pause this because I only have about 20 seconds left, and I'll continue here in 1 second.